Hello everyone, my name's Nico, and today we are going to be making this. Let's get into it. Alright, so the first step is to set up our Java IDE. I'm using processing, which is a Java library that makes it really easy to render 2D and 3D shapes. And all we need to set up just a little window here is a setup function and a draw function, and then just defining our window size, and it should pop up with a window. The next step is choosing our image for the EQ. I chose this image because it has a circle around it and I want to wrap my EQ around that circle. So the next thing that we have to do is just import that image and display it on our canvas. This part is easy. All I have to do is make a processing image object, initialize it, and use a function in our draw method to put it on the canvas. Now that we have our image, we need an audio library. The library I'm using is called Minim. Minim is a library that allows for simple audio and frequency analysis, as shown in this example code. The example uses three objects to make this work: a Minim object, an audio input, and an FFT, or fast Fourier transform. Fast Fourier transform is a method of converting an audio signal into a bunch of frequency signals, which we can then interpret to draw lines on the screen. After studying the sample code for a few minutes, I got to writing the code for my script, which is basically just copy and paste for now to make sure everything works properly. The audio input uses the Minim object's getLineIn function to get the audio input of the computer. I was able to get the audio from my desktop routed through an input using the stereo mix on Windows, but I believe you need a third-party program like Soundflower for this to work on macOS. This for loop is where most of the magic happens. The analyzer has a list of frequency bands, which we can loop through and get the intensity of each one. Each loop draws a new line that's a few pixels over from the last one, for each frequency on the list. I use an integer to decrease the amount of frequency bands the for loop goes through, because no music uses more than around a third of what the analyzer returns. In the end, this will look better, but it has a few drawbacks that we'll talk about later in the video. After copying and modifying a bit of the sample code, I was able to get the lines drawn on top of the image based on their frequency. Now we have to define the circle that is at the center of the image. I did this by drawing a circle in the center of the screen and changing the radius and position by a few pixels until I got the drawn circle mostly lined up with the circle on the image. Once I found some constants that I was happy with, I moved on to the next part of the project, which is moving the lines from the corner of the screen to the circle. This requires a bit of math to do properly. First, we need to calculate how far apart each line needs to be from the previous one. I decided it would be smart to render each line at a specific angle on the circle using trigonometry, which means we need to calculate how many radians are going to be between each line. Since a circle contains 2 pi radians, we're going to have 2 pi radians per n number of lines. This makes a simple ratio of 2 pi over n, where n is the number of frequencies that the analyzer returns. We can then iterate our render angle by the defined render ratio and use the cosine and sine of the angle to determine where the first point of each line needs to go. And making sure we transform the lines to the defined center from earlier. Almost. It looks like for some reason the radius is doubled, so let's divide that by 2 to make everything fit. And the last improvement to this is adding 10 pixels to the radius so the lines are visible when they're really short. This will make the end product look a little bit cleaner. The whole thing looks a bit strange right now, but it will all come together soon. Now for the second coordinate of the line. The strategy I used for this was taking the first point and transforming it outward, using the same angle that it was drawn at on the main circle to ensure that the line is always straight. I can then multiply the trig ratios by the frequency intensity, which determines the length of the line. And it works. But there are a few visuals that I still want to change. First, the lines are going clockwise, which is kind of counterintuitive from a mathematical standpoint. This happens because in processing, the y-coordinate is inverted, meaning the top of the screen is y equals 0, not the bottom. This is an easy fix. All we have to do is change all the addition of the y-coordinates to subtraction. The second problem I have with this current iteration is the difference in length of the lines. The lower frequencies are much higher than any of the other frequencies on the circle. My first idea to fix this was to get the actual length of the line using a distance formula, then if the line length is above a certain threshold, multiply the x and y by a half. However, this obviously didn't work because we're totally disregarding our line's angle. The solution I ended up on was to redefine the second point entirely, giving the point a constant height whenever it passed the threshold. After fixing some addition-subtraction issues, the resulting output clips the lines that are too long beautifully. I also added a bit of random height to all of the lines to give the visual a bit more liveliness. There are a few drawbacks to cutting down the range of the FFT analyzer. You can see when I make the range higher, there are a lot more lines, which can make the result look a lot nicer. However, just increasing the range isn't enough, as only a quarter of the circle ever has lines that move. Because of this, my only option is to use a shorter range. Since there's no way to increase the accuracy of the FFT, we have to fake it a little bit. We're going to draw 2 lines per loop. The first line with the actual FFT frequency, and a line whose height is an average of this line and the line before it, doubling the amount of lines while keeping a realistic look. I started by making a line class that holds 4 values, x1, y1, x2, and y2, that define our line. I then initialized a new line called last line at the start of my program. I then made an average function that made my life a little bit easier. The final 2 steps were actually creating the second line with the average of this line and last line, and then setting last line to this iteration's line. I made a method inside of the line class called setLine that does the same thing as the constructor, except I don't have to make a new line object every single time. And here is the end result. so that is my little visual EQ. It definitely turned out a lot better than I expected it. I'm really proud of the little thing I made. This is my first little video of LoFi DIY. So yeah, I hope you guys enjoyed. See ya.